לראות שהטמפרטורה בין הלוחות של הדאבל סקין, בין החזיתות של הדאבל סקין, בין שתי השכבות, לא תעלה על 60 מעלות, תהיה איפשהו בין 50 ל-60 מעלות, ומעבר לזה, במידה ואנחנו נצטרך להזרים פנים האוויר, שמהירות האוויר לא תעלה על 4 מטר לשנייה, מכיוון שמעבר לזה יש נפנופים, יש איזה מין תופעה כזאת של התריסים שמתחילים להיכנס למין ויברציה כזאת ומשמיעים רעש מטריד בתוך הבניין. והתוצאה או האופטימיזציה מהחישוב הזה היא צריכה להיות שאנחנו את אותו אוויר בפנים, אנחנו צריכים לדעת גם איזה כמות של אוויר אנחנו נאלץ להזרים פנימה. אז אם אני חוזר בתמצית קצרה לגבי המערכת כולה, יש לנו את המערכת של הסקין החיצוני, שהוא בעצם זכוכית רבודה, בשתי שכבות עם PVB באמצע, הזכוכית היא זכוכית נטולת, או עם תכולת ברזל נמוכה, היא זכוכית שקופה לחלוטין, יש לנו את החלל ביניים, שזה החלל הזה שהוא כמטר בערך, כאשר יש בו מדרכים שמאפשרים 85% של מעבר אוויר, כי כמו שאמרנו, האוויר זורם כאן, זורם לאורך החזית ולמעשה מקרר את החלל, ויש לנו את השכבה הפנימית שהיא מורכבת מיחידה של זכוכית בידודית, שמורכבת משני לוחות זכוכית, האחד הוא זכוכית לאו-אי, אתם רואים ששתי הזכוכיות מטופלות בצורה שונה, אחת מחשב עצמאי. הן מטופלות בצורה שונה, אבל זה עוד פעם כולל הזכוכית שהיא בפולי טמפרד, היא עוברת גם מבחן של היטסוק, כדי למנוע שבר ספונטני בזמן חיי הבניין. הניתוח הבא הוא בעצם היה ניתוח ממוחשב של מה קורה בתוך החזית. בחרנו חזית אחת, למרות שהיא לא החזית הבעייתית ביותר, אבל פשוט זו החזית שאני מדבר עליה. וניסינו לראות מה קורה ללא בלואר, ללא נישוב מאולץ או תנועת אוויר מאולצת בתוך החלל, אלא רק על ידי הסעת אוויר בתוך החלל, ומה שקורה ללא הבלואר, אנחנו רואים פה שיש לנו זמנים שהטמפרטורה היא בין 50 ל-60. עכשיו, להסביר מה הבעיה בין 50 ל-60, המשמעות שהטמפרטורה עוברת את ה-60 מעלות, זה אומר שהדלטה T, הפרש החום בין החוץ לבין הפנים, שהוא סדר גודל של 25 מעלות, בעצם יגרום לזה שהקיר הפנימי יהפוך להיות לרדיאטור, זאת אומרת, הטמפרטורה שם תעלה, וכשניגע בזכוכית, בעצם הזכוכית הזאת תהיה חמה ותקרין חום פנימה, לא יהיה נעים לשבת בפנים, גם אם לצורך העניין לא תהיה קרינה ישירה, ולכן זאת ההתעקשות להגיע להפרש הזה. מה שאנחנו רואים, אנחנו רואים כמה דברים. קודם כל, בחורף, בשני הקצוות, זה נחמד שיש לנו טמפרטורה כזאת. אני מזכיר, בחורף הקוויטי סגור, והוא למעשה הופך להיות כמו תנור חימום, או כמו סמיכת פוך שעוטפת את הבניין, אבל כשזה מגיע לחודשי הקיץ, הדבר הזה הרבה פחות נעים, ולכן אנחנו צריכים לראות מה לעשות. כאן אתם רואים את התוצאה של הבדיקה, ואנחנו רואים שהחזית הדרום-מזרחית, לא דבר לגמרי טריוויאלי, הבניין לא עומד צפונה לגמרי, אבל דווקא החזית הדרום-מזרחית, היא החזית שמקבלת את הכי הרבה שעות שמעל 50, וגם מעל 60 מעלות צלזיוס. ואז נכנס הניתוח, מה קורה אם אנחנו מתחילים לנפח, להעביר אוויר בתוך הקוויטי, בתוך החלל הכפול, ואתם תכף תראו במצב התחלתי, ואנחנו מתחילים להכניס 5,000 CFM, 10,000 CFM, 20,000 CFM, אתם רואים שהטמפרטורה יורדת. זאת אומרת, ככל שאנחנו מעבירים יותר אוויר, יותר הסעה של החום שכלוא בין שתי החזיתות, אנחנו מורידים את הטמפרטורה, דבר מאוד משמעותי. דרך אגב, הוא משמעותי גם אם אנחנו נרצה לגדל בין שתי החזיתות האלה בעתיד, נרצה לגדל ירקות, כמובן שאנחנו לא יכולים לעבור טמפרטורות מסוימות, כי פשוט שום דבר לא יגדל בתוך אותה טמפרטורה. וזה למעשה מה שהכתיב בסופו של דבר, שאותם מפוחים שנמצאים בתחתית הקיר, יזרימו אוויר בכמויות שונות בהתאם לחזית של הבניין. רוצה לומר, אנחנו בעצם מדברים כאן על מערכת שהיא מערכת טכנולוגית, לא רק מעטפת אקלימית, אלא מעטפת אקלימית שהיא מעטפת אקטיבית, שבעצם מושפעת מתנאי הסביבה. כמו שאמרתי, יש לנו במבנה עצמו, יש לנו הרבה מאוד מערכות, יש לנו 5 מערכות שונות, אנחנו התמקדנו כאן, אוקיי, תצטרכו לסבול עוד קצת, ברגע שיהיו קולות מחאה אני פשוט אעצור, איריס מראה לי שיש עוד 5 דקות. אוקיי, אז אני בעצם מתמקד בראשון, או התמקדתי בראשון, ואני אראה לכם גם קצת לגבי מספר 4, קיר מסך כבלים. קיר המסך של הכבלים, כמו שאמרתי קודם, נמצא כאן, יש לנו כאן אטריום בגובה של 42 מטר, ואנחנו החלטנו באתגור, יחד עם השותפים שלנו, שלמעשה כאן אנחנו הולכים לעשות מערכת שהיא מערכת כבלים, והסיבה היא, אתם תכף תראו אותה. אני אעבור הלאה, אני אדלג קצת ברשותכם. כאן מה שאנחנו רואים את התכונות של המערכת שקיבלנו, מה היא נותנת לנו. בין השאר, הדלטה T שהיא אמורה לתת לנו, זה 25 מעלות בין החוץ לפנים, זאת אומרת שבכל יום מיומי השנה, כשאני אגע בקיר הזה, הטמפרטורה לא תעלה על 32 מעלות, זאת אומרת, המערכת של הקיר מסך מבפנים תהיה בטמפרטורה שהיא מתחת לטמפרטורת הגוף, מבחינתנו הקיר הוא לא הופך להיות לרדיאטור של חום. את זה אנחנו ראינו. עכשיו, מה שאנחנו יכולים לראות פה בחתכים האלה, זה קצת איך נראית המערכת של תחתית הקיר, עם אותם מפוחים. אוקיי, אתם רואים כאן את המערכת עם הפילטר, ואם אתם שמים לב, כאן בקטן זה אותו צינור שעושה פו בערב, ולמעשה מנקה את הפילטרים ומאפשר את זרימת האוויר. זה בחלק התחתון של הקיר, כך היא נראית, וכך נראה החלק העליון, כאשר אתם רואים כאן את האפשרות גם של מעבר חופשי וגם של מעבר מאולץ על ידי מפוח, בהתאם לטמפרטורה שיש לנו כאן באותו תווך. המדרכים כאן מאפשרים טיפול במערכת של התריסים והצללות, שיש להם חלק משמעותי במניעה של חדירת אור פנימי לתוך הבניין. האלמנט, כפי שאמרתי, המשמעותי של התריסים, הוא אלמנט חשוב מאוד, כי הוא בעצם מאפשר לנו לבסט את הבוהק בתוך המבנה, ומאפשר לנו למעשה להגיע קרוב לחזית. מי שמכיר בחלק מהמבנים, חלק מהמגדלים, אחת הבעיות הגדולות שיש, במיוחד במגדלים שנבנים על ידי יזמים שמזכירים את השטחים, זה שבגלל שהמערכת היא יחסית מערכת פשוטה, שמאפשרת לחדירה של קרינה ישירה לתוך המבנה, לא ניתן כמעט לשבת במטר וחצי, 2 מטר שהם ליד החזית בהפניות ספציפיות, בעיקר דרום, מערב וכולי, והדבר הזה בעצם פוגע גם ב-well-being, בשלומות של העובדים שנמצאים בתוך המבנה. ולכן המערכת של התריסים, שהיא מערכת שניתנת לפיקוד בצורה ממוכנת ממערכת בקרת מבנה, יש לה חשיבות מאוד גדולה בתוך הסיפור הזה. חזרנו פנימה, אני מדי פעם מרענן עם מבטים מתוך החצר. אוקיי, אז אנחנו יכולים לעשות או הפסקה או לעצור, אני אעבור ואני אראה לכם רק את המערכת הזאת של הכבלים, זאת המערכת הזאת, שבעצם סוגרת לנו אטריום של 42 מטר, שכל כולו בעצם נתמך על ידי כבלים, כדי שיהיה מעניין, אז גם החלטנו שהאורקיה, הסקיילייט, בהמשך יהיה גם במערכת מתוחה, דרוכה על ידי כבלים, ושיהיה עוד יותר מעניין, המערכת הזאת גם היא מקבלת טוויסט, ככה זה נראה מלמעלה, מהגג, זאת המערכת התומכת בפנים, ולא שכחנו את את מי שצריך לדאוג שהזכוכית הזאת תהיה נקייה. כך המערכת נראית מבפנים, 42 מטר גובה, לא מעט. וגם כאן אתם יכולים לראות בפרטים המטורפים שיש כאן, של המערכת, זו פשוט מכונה. מכונה טכנולוגית מאוד, מתוחכמת מאוד, שבעצם לוקחת בחשבון שהמערכת הזאת היא מערכת דינמית, היא מערכת שעובדת, היא נושמת, אותו קרום של זכוכית, ואנחנו צריכים לדעת איך בעצם לקבל את הכוחות, ואתם יכולים לראות כאן שבתחתית יש מערכת של קפיצים, שמאפשרת לכל הקיר הזה לנוע גם בתנועה ורטיקלית, בהחלט מערכת מרשימה מאוד. אני אתקדם עוד ורק אראה לכם, וזה התחילו להראות קודם בהרצאה הקודמת, את הנושא של החשיבות של המוקאפ. אנחנו בעצם עבדנו יחד עם החברה המבצעת על הקמת מוקאפ, שבו בעצם עשינו את הבדיקה של כל אחד מהרכיבים, אם זה הגוונים של האלומיניום, של התריסים, של הזכוכיות, של הפחים, של פחי בקופסאות הצל, כל דבר שבעצם יכול לעזור לנו לדמות את המצב הסופי, כי ברור לגמרי שמגיעים לבניין, אין לנו דרך חזרה, ואתם רואים, פשוט בנו לנו במפעל במישור אדומים, בנו חתיכת חזית שיש לה את כל התכונות של הבניין, ובדקו עליה את כל הדברים שאנחנו נדרשנו לבדוק. אתם רואים את התריסים, אתם רואים גוונים שונים של אלומיניום, ולמעשה זה אפשר לנו. זה המצב פחות או יותר של הבניין היום, לקראת גמר חזית. טוב, הפרויקט הבא שאני כנראה, או שאני אראה אותו אחר כך, אנחנו נעשה עכשיו הפסקה, איריס, הכל בסדר. זה פשוט, אני רק אתן הקדמה, אם זה יהיה מספיק מעניין, נחזור אליה. זה בניין אחר שהוא כרגע בהתחלת ביצוע, כאן התפיסה אחרת לגמרי, החלטנו לרדת מהדאבל סקין, ואנחנו למעשה את כל המעטפת אוסחים בעזרת זכוכית אלקטרוכרומית, זאת אומרת אנחנו מקבלים ביצועים אקלימיים דומים, בעובי זכוכית בעובי קיר מסך של זכוכית בידודית כמעט רגילה, העסק לא פשוט, במחיר הוא פחות או יותר משתווה, אבל ההמשך, אם יבוא אחר כך. תודה בינתיים.
אוקיי, אנחנו חייבים להמשיך, נמצא איתנו joining us, last please, and sorry for the delay. Let's start again.
Hello?
Can you hear me?
Is the screen shared now? Can you hear me?
Yes, absolutely. Can you hear us?
Oh, okay. I can hear you as well. So I think we might get lost as per the translator in some reference slides where I'm going to jump back in to not pull you in the same opening as before, but I'm not sure. This showing here always that the host did not allow me to share my screen, so I'm a bit helpless. Is the presentation now online or is the presentation online? No, it's not, huh? Oh my God. You need to allow me to share my screen. This is by the technical people running Zoom in Israel. Emil, kannst du mal kommen? Aber ich glaube, wir können da sowieso nichts machen. Jetzt hat er mir erlaubt, den Bildschirm zu teilen. Wie ging das jetzt weg? Okay. Is the presentation now visible again? Hello?
Yes, it does.
It does. Okay, then we might. Wo liegt jetzt von dieser Folie? Yeah, okay. Well, we might be back online now. So I showed you a few references from the world. In Russia, we speed that up a little bit, Asia, and we are working in the Americas as well. So mainly we haven't done anything in Israel. I traveled a couple of times into your lovely country before Corona locked us out again. And I'm just in hope in future that out of the good collaborations and network we started to build in Israel, we are allowed to help you or support project there as well. As you know, the interface of architects and consultants relates in these days a lot to sustainable designs. It was in the past more the constructability of projects, but the environmental change requires now to bring more sustainable projects into run. And so a lot of our work relates to our thermal physics division we are having in-house. Still, facade consultants have to balance quality, cost, and time. You are fully aware of that. And what we saw a bit as a withdrawal in the past is that the design responsibility and the execution responsibility was very hard divided contractual. And I will show you later in the presentation that we see a certain change. The BIM approach requires digital data transfer from the designing team, the tendering team, into the execution team. Design to machine is an interesting thing that builds joint responsibility, and we try to get organized for that. So let's go in active and adaptive. Curtain walls who can adjust their behavior and performance as per the environmental change. We just saw double skin facades with integrated blind systems who can do so, and the environmental change in things getting more warm, more wet, more cold is something what requires more flexible curtain walls. So I would like to show you from our R&D division some adaptive building skins which adjust per this demand. But the reality in the world, in the Middle East and in other parts of the world, is still quite different. The majority of projects are glued together. They use reflective glass, and that is not the future of curtain wall, as you know. So what the simplest solution is an external shading element, what we use still in Europe a lot, but that is limited related to height. You know that these external shading elements are not available when harsh winds come around. And in certain projects, we use different materials for external shadings. In the Thyssen headquarters, a quite advanced solution is executed where the external shading element is acting like the wings of birds. They are quite flexible. The building system is driving it as per the sun. The whole system is foldable and twistable to allow different sun to get in. It's a very advanced solution for a headquarters where a steel giant wanted to show what they can do. The whole shading is built out of stainless steel, quite costly, 2,000 euros per square meter. Obviously not applicable for all the projects, but it shows at least what can be done, that these technology can be customized as per project, and that is where we had a main influence on the execution, but it is not a cheaper solution, as you can imagine. So when it comes to price-wise, more interesting solutions for courtyards and all this, we are working from time to time with Ptfe Cushions. You can see that on the right side of the screen that it is a double layer cushion. So we can pump light. We can pump air into different areas of the cushion. And related to this, we can adjust the shading because on the external layer and the mid layer are dots printed. As you can see here, and when we pump more air in the lower cushion, we bring those dots together, and then we can control the shading coefficient of a foil roof. Honestly, that was quite important for the aquarium, what you see on the left side, because there was only a temperature difference of 2 degrees allowed with the acrylic glazing, and so such a control system is a common standard, but still an advanced solution you can use. Structure is very light, so it can be used for historical courtyards to close them and adjust. You might be aware of the elder approach of the 2-degree concept of Schuko, where you slide different layers in front of windows. And then obviously you are fully aware of closed cavity facades, what is introduced from Gardner a longer time back. And I know that you advanced companies in Israel are using this technology a lot. You have the shading element in this cavity protected and can work with that. It requires a certain space, buildable space, and it comes with a certain price tag, obvious, but it is a great solution to work with that. We had the idea to reduce the investment and still work with a kind of double skin in a smaller package. And I would like to show you the ACT facade, active cavity transition facade, what we developed in our facade lab jointly with others. Our client wanted one of those fully glazed building. You see Mies van der Rohe on the left, a long time back from the 30s, and the middle project is finally built on that plot. The right one is the Festo headquarters in Esslingen near Stuttgart. And these clients wanted in Germany a fully glazed building, what is not that easy related to our ecological standards in Germany to achieve. So the client contracted us to review what can be done. This is the final project, and I would like to show you what we developed for that project. It is called ACT Facade, Active Cavity Transition. And we got inspired from the exhaust air facades some companies used in the early 80s, where the insulated glass unit is outside, a single layer glass unit is added on the inside, and then the air system is floating through this cavity to take the temperature impact from outside into an exhaust extraction system to work with that heat. The smartness of that system, what you see, is not that it is creating a different U value. The smartness is related to physical engineering. What we need to understand is that your body is reflecting on what we call resultant felt temperature. When you want to feel 20 degrees in a room and the inside of the glazing is having 28 or 32 degrees, it is giving you a certain unbalanced situation. The other surfaces in the room are cold. The surface of the glazing is very warm. And then it requires that you cool the room on 18 or 18.5 degrees to give your body the feeling to have 20 degrees, related to the fact that the inner glass surface is so warm from the sun. With the additive inside glazing, this inner glazing is having room temperature, and that creates a situation that you don't have to cool the room on 18.5 degrees anymore. You can pump air in there with 20 degrees and you feel 20 degrees. So the saving is not the difference in U values of the curtain wall. The saving is a difference in surface temperature, what allows you to lift up the temperature and to save a lot of the cooling load. So we wanted to use this further and had the idea of using the inner blind system to save the additive glazing inside. And the blind system is required anyhow for anti-glare situations. You see them in all the offices. So we worked with a specific fabric to establish this cavity, and it finally worked out. This is something what can be installed, and the rollers are going down. And we created a little movie about the solution, which hopefully runs, where you can see that it is a regular insulated glass, but single layer curtain wall. You just hang in a unitized panel, very simple. Inside is the anti-glare blind system installed. And when it comes down, we suck the air above that cavity through this system and take the heat right away before it reaches the room. The advantage of the blind is that it is material-wise very light, so it doesn't radiate that much, and it's even more sufficient. You can use it in half positions or full positions. So it provides a double skin solution with a cavity without paying for a double skin facade and without investing this much money. It is just, we tested it in Fraunhofer Institute prior to execution. We measured and found amazing results with that solution. The project is in use now for 2 years, and there is a saving on roughly 25% cooling load, which is really exciting against a minor investment. We built it in our lab, a mock-up, to show the advantage of this. There is a double skin facade next to a closed cavity facade, next to a box type window, and then the last one is the exhaust air facade. And what you see in the inside picture is the depth of the facade. And we discuss rentable space. Owners who build are normally on plots limited in the outside perimeter of their project. And when as you can see, there's a 650 millimeter saving in depth with our ACT facade against a deeper double skin facade. And if you can rent out on each floor 650 millimeter around the perimeter in 20 or 30 floors, you can assume how much saving is happening. Here is a ground floor, again, to express that. So mainly you can see that the rentable space is so much bigger, what creates assets for the owners. And the investment on a single glazing facade with a regular stick system or a relatively simple unitized, the execution cost is so much lower that it is really a beneficial approach. What we did as well in the project, there where the openable windows are, the architect wanted a certain highlight, so we used switchable glazing there to tint those glazing, that when the sun is coming around, these glasses are tinted, the other ones are shaded with the blinds, as you can see, so that a certain creative image is changing over time and over the usage. The client has asked for some more innovation in this project, so we looked for the cleaning approach on the project. We found in Switzerland a very advanced cleaning robot, cleaning normally photovoltaic cells, and with the help of those people, our client himself, we changed this into a vertical cleaning robot hanging on a carbon fiber rope where the water is going through, and that is finally cleaning the external smooth surface. Obviously, there are limitations. When it is a flush surface, you can easily clean with this robot the surface. It is 7 times faster than human beings, and it doesn't look into your room in case that it is a hotel or something. Nobody wants in the morning these cleaning people looking on your underwear or whatsoever. So we see a bigger advantage in this and hope that it can get further into projects. It is really quite interesting. And as a washing machine at home, it is saving a lot of water related to efficiency. We achieved a DGNB Platinum, which is the highest energy certificate in Germany, what expresses the workability of the solution, and some more figures, 10 to 20% reduced cooling loads, amazing U values in a very low depth of 75 millimeter facade. This is quite something. This solution then went through a curtain evolution and ongoing projects. We are doing with this solution right now the Continental headquarters in Hanover. Here, mainly, the new challenge was the width of the blinds. The format was much bigger than in the other project. So we developed with the zip system of these shading elements that we can span bigger in depth. We tested further in Fraunhofer Institute, the comfort issues and all that, what came out good, smoke tests through the blind showed us that the airflow is working perfectly, and that went into execution. Further, we developed the system now for geometrical, more challenging projects. As you know, textile blinds can follow these things by being pulled up from down upwards, for example, and that works quite interesting as well. And then we checked on the potential of the act facade for refurbishments, and this is so important for the green future of our planet. It will not help to just build new projects more energy efficient. It is so important that we work on the existing curtain walls. So the Euro Tower in Frankfurt, which was the home of the central bank in Europe prior, you see the elder project on the left, the new one on the right. We refurbished the old project with our act facade by just keeping the external facade as it is, and we added the internal blind system, as you can see in the hand sketch. And based on this, we increased the comfort just by changing the inner blind system into an act facade approach. We could keep the insulated glass unit, and the comfort is so much better. Energy saving is established, but we kept the facade. And very often clients don't want to rent, take all the clients out of their projects. So this is a very creative solution to tackle existing facades as well. Act facade success by not limiting architecture. We had a project in Taiwan where the architect didn't want the textile blinds, he wanted lamella systems. And we understood that our approach should not limit architecture. So you see the Taiwan project in the middle. That pushed us to start thinking about what we can do else, pulling those blinds upwards or downward, that we breeze through the screen, or that we use different gradients of screen. All this is being tested. But what we checked now is that workable with Venetian blind systems inside as well? And that came out as a very workable solution. What I will show you here, there was a design challenge competition in New York on an existing elder project from the 17th in Madison Avenue, and Friedemann approached this design challenge. Hello? We got cut off again? Hello? Hello? Can you hear me?
I can hear you, but I don't hear them.
Oh, so most probably we got disconnected again?
It looks like it.
Are we back online? Hello?
We've been cut off.
We're cut off.
I
Okay.
think. Oh, great. Well, it was good so far.
But we have a good connection, right? It should be
Yeah,
not my
yeah.
connection in Germany, huh?
Yeah, I don't know. Something's wrong there for some reason. Oh, we're still live on YouTube, apparently.
Let's see.
And we're
Hello?
being recorded.
I think we are back. Are we back online?
Yes, can you hear me?
Yes, I can hear you. Can we go ahead?
Yes, but unfortunately, we have 5 minutes longer
What do you mean?
for your lecture. To your lecture, we have only 5 minutes longer.
You stole me all the
You
time
can
and now
go
you're
on.
telling.
For...
Okay.
No,
Well,
no. What I mean, from now on, you have
5
5 minutes longer to
Okay.
finish the lecture. Okay?
Okay. Well,
Brilliant.
you will
Thank you.
just stop me when it is gone. I'm not sure if I can finish that in 5 minutes. Anyhow, let's see where it takes us. So I hope that I'm back online with the audience. we used the act facade in a project in the US to use the inner blind systems, and then I speed up the process a little bit to take you through that. So mainly we worked here with Venetian blinds to control the heat, the perforation was selected to allow the closed cavity or the act facade, in our case, to work appropriate. And that came out similar to the Venetian blinds. So even with, similar to the textile. So even with Venetian blinds, we can go forward. And there are so many elder buildings in New York where this technology can be used. So we are evaluating currently where is interest of clients to use that. Let me show a little bit our home, our kitchen. That is our headquarters in Germany with the mock-up space outside, and that is inside with the exhibition where we have forums when people come in to look on all the samples and all that. It is helpful for clients to select material. We are not selling material. We support the selection. Outside is the space of showing these technology on mock-ups, and in that, obviously, we have our office spaces in here, and this is where we jointly work. Why do I show you that? We work a lot of energy harvesting technologies. BIPV, building integrated technologies, are used, and if you can measure something, you can improve on it. And so we installed thin layer photovoltaics in our own facade to learn from that. We are using heat pipe systems to learn about how to produce hot water, to use it further on our own mock-ups. In our R&D division, we created jointly with the Technology University in Dresden an energetic panel where actually we use a combination of photovoltaic layer outside and the heat pipe system inside. The advantage is that the backside of solar panels are getting very warm related to the absorption. With that additional heat, we are working in those piping systems to extract more energy of that and bring it back into the curtain wall systems. That comes out with a very high efficiency. It's quite interesting, and we're having measurements always in the run to understand the results of these technologies. The panelization is finished, and we are taking that into a project. Another project in our R&D is called Ptfe Solar. There are lots of joining partners. This is in cement concrete, an approach where intercapillary systems are embedded in the concrete already to avoid the combination of additive material. That is quite interesting because it is solid. It is very easy to recycle, but the stream of fluids are going directly into the panelization system. You can cover that outside with glass or not. That depends on individual taste. It was exhibited in the Munich Bau last time when it worked, and we are using it right now on smaller projects to check the workability. And on bigger projects, it is in plan. These are new technologies. Sorry for speeding up, but I got told that I have to. These heat pipe systems allow further developments to extract energy out of panels. The Arcol strip heating thing is embedding those heat pipe systems into glazings seriously. There is a pattern used on a bigger project to get energy out of that external building skin. As you can see here, there's a smaller test running in a smaller village. What is always wise to see the workability of these solutions. We have taken these heat pipe systems now even into a shading system. The Venetian blind is shading our building and at the same time extracting energy from those heat pipes. It is the Arcol solar thermal Venetian blind system. It is quite costly. It is a kickoff. It is an investigation of what can be done. Not really in position today to be installed in large scale, but in a smaller sustainable project in Germany, it will be embedded. We tested that to fold the lamellas and all that in Germany, and it comes out with quite impressive results. In the beginning of technology, technology is often a bit more costly before it achieves a good price ratio. We exhibited this in our lab as well to the audience to see what is the reaction. Adaptive shading can be taken further. That can be interesting, most probably for projects in Israel as well. We're working right now on a product called Adaptex, where we use shape memory alloys to change the shading element's position. That is extremely interesting because it requires nearly no energy to adjust as per heat. These shape memory alloys have embedded in their DNA positions related to temperature. If you have something like this in a closed cavity facade, for example, when the cavity is heating up by the sun coming around, as per arrangement in the DNA of the material, we can adjust, for example, the adaptive wave or the adaptive mesh technologies. I think there is a little video showing how this reacts when the heat is changing, that those lamellas are closing like an eyelid, the shading elements, and then it is reopening when it cools down. That is an interesting approach, I think, and an architectural, very nice feature. At the same time, we are doing this with double layer mesh systems, textiles. We are sliding in front of each other, what you can see on the left side, to adjust the shading as well, to not only depend on inner temperature and the cavity. There is an additive system where electrical wires can be heated and then change manual where you would like your heating or your shading system to be in future. These are mock-up pictures in our lab of the Adaptex system, where we have a good feedback from the market because it is an interesting feature coming soon, and it is now decided to be installed on the Echo House project of the German University in Oman, where we can see it live in work. There was a workshop happening in our lab just recently where we showed this technology to the visitors, and it is getting used, for example, on an energy speicher in Heidelberg right now. I'm not sure if I have still some more time. If not, you just have to stop. We have a digital twin team working with technologies like this, and these guys are running the digital twin team. One of them is Sven Böke, who worked on thinking skin technologies in the past, geometrical work, but more important for you is actually the cyber physical systems we are having in run. This is based on Industry 4.0, the understanding that components itself should talk to each other, that they have a network of components driving themselves. And the idea was, can we transfer this into our energy solutions in facades? Can the air inlet talk to the shading element and talk to the heating or cooling elements? And there is a testing mock-up being created where we tried with little things to see if such technology can work. It is a cooking kitchen, as you can see, a manual approach. But interesting for you is that these shading systems are talking to each other in the understanding that one shade is telling the other shade if he is still working or if he's damaged or not. Or for example, when on the right side the lamellas are closing, then on the other side the technical systems are starting to operate, and vice versa. That is a future that you don't have to write in a bus system who is doing what. They're guiding themselves to take the best results into play. The BIM 2D and 3D workshop workflow is something Michael Grau in our division is working a lot on. BIM is creating, as I told you, a data transfer from design to execution. It is more a joint work with a joint liability. And we are using this understanding now by asking our clients to allow us to work with them in the pre-tender stages and then maybe join the execution to work more in detail in BIM. We developed a strategy how to do that. The first details of projects are detailed in shop drawing quality, as you can see here, very much in detail, but that is too much data for a Revit BIM model that it can be handled in future. So we are simplifying these construction detail in coordination with our customers, and then we transfer it into Rhino to do all the optimization processes. And after that, it goes through a converter to be available for use of our clients in their BIM models. That sounds very simple, but coordination in BIM is very important because it is a tool where you need to have a joint language, and that comes out quite interesting. And when we detailed certain areas, we can exactly define the space you need for the fabricator in future, that wherever the superstructure is decided to be, that before the shop drawing design is done, everything is organized in a way that it can work. So we offer BIM services in 2 stages. Stage 1, in what we call LP3, the early design stages in Germany. In that stage of the architect, we work already in the final design stage to create details workable. Then we give our clients, the architects, typical submodels that he can embed those models in LOD 300 or even LOD 350. Yeah? Hello?
I'm terribly sorry, but our yes. Can you hear me?
Yeah, I can hear you.
I'm terribly sorry, but our time is up.
Okay, then we just have to skip the rest. I'm sorry, but if we lost so much time on that, I'm sorry to say that I cannot finish that. It was a pleasure to talk to you. There would be more to show you, but at least I gave you a little bit from our R&D division, and I wish you a wonderful day in Israel and interesting presentations from the first-class people you invited to do so. I say goodbye from Germany and wish you all the best. I hope that I can come next time in person to present the rest to you. Okay? Bye-bye.
God bless you. Thank you.
תודה רבה. אדיר לוי, מנכ"ל קוסנטינו, אני רוצה להגיד שחלק מהדברים כמובן נוגעים בעיצוב, נוגעים בנושא של קירות משולבים בקטון, אז בבקשה, סך הכל מדובר באמת באחת החברות שפעילות